It's given that the power delivered by this 3 ampere current source is 21 watt. So this is the current Ix, and this is a controlled current source Gix. So we need to find the value of G. What is G? That's the question. So this power supplied by the current source is 21 watt. So Vi is 21, I is 3, so V is equal to 7 volts. That's the voltage here. So if I assign the polarity, this should be in the direction of the current, since it's a source. In the direction of current, it's a rise. Now let's label these low nodes. This is A, this is B, this may be C, and this is D. So also we can assume some currents here. So let's assume this current is going this way, which is IA, and since this is going through a resistor, the drop is in the direction of current. This one, let's assume the current is going this way. Let's call it IB, this current IB, and the drop will be in this direction. This one is IC, so drop is in this direction. Now let's write KCL at node A. So KCL at A, and we have Ix as entering, IA and Gix as leaving currents. So from here we can say IA is equal to Ix minus Gix. So this is 1. Then let's write KCL at node C here, which is this one. This is C. So here IA is entering, IB is also entering, and 3 is the leaving current, comma here. So IB is becoming 3 minus IA, which is 3 minus Ix plus Gix. So that's IB in terms of Ix and Gix. And then let's write KCL at can erase this part. So KCL at node B, maybe KCL at B. So again IC is entering, 3 is also entering, and Ix is the leaving current. So IC is Ix minus 3. Yes, so these are 3 currents. Now let's write the for loop ABC. Let's in that order. Let's write the KVL for loop BAC in the clockwise order. KVL. So this one will have drop in this direction. Let me use black now, maybe. So 1 ohms Ix, that's a drop. IA 2, that's a drop. Sorry, this is Ix. And then the third one is a rise, which is 7. So yeah, so Ix plus 2IA is 7, or we can say Ix plus 2Ix minus 2Gix. So basically instead of IA I am writing this expression this side, so it's becoming 3Ix minus 2Gix is equal to 7. This is one equation. Another equation we can write similarly for loop BCD, again in clockwise direction, KVL. So now going from B to C, this is a drop to 7 volts, so let's write as a plus here. Then C to D, that's a rise, so basically it will become a negative now. So negative 2 IB, and then D to C is again a drop, so that's 2 IC, that's 0. So it's becoming 2 IB minus IC, IB, IB minus IC. So let's think that we have taken it on the other side and 7 remains this side, so that's like that, remains on this side. So IB is 3IX, 3 minus IX plus GIX, and this one is IC, which is 2 IC, 2IX minus 6 is 7. So I will have to write here maybe somewhere. So yeah, so that's becoming 6 minus 2IX plus 2GIX minus 2IX minus 6 is equal to 7. Actually this should be a plus because that was a negative, so yeah. So it's becoming minus 4IX plus 2GIX, and this is 12 going on the other side, so 7 minus 12 is minus 5. So yeah, that's equation 2. Now, so looking at equation 1 and 2, we can see there are two unknowns, Ix and G, and these are two simultaneous equations, so we can just solve this equation to find the value of G. So I won't do the solution because it should be simple. What we can do here is multiply 1 by 4 and 2 by 3 and then add, or yeah, actually what we can do first to get rid of this part, we can just add these two equations, so it will become minus Ix is equal to 2, so Ix is equal to 2, something like that, and then we can substitute back to find it. But anyway, it looks that it's possible to do, so I will leave it here. But this is how this problem can be done, and please leave your comments if there is any.